Dear students, yesterday I have explained an important concept called forward bias and reverse bias. So let's very quickly revise these two topics, and then we'll learn two important questions from the exam point of view. So definitely one of the question will appear for the board examination. So that's why listen and then focus on the explanation. So in forward bias circuit, the positive terminal of the diode is connected to the P region, positive terminal of the battery is connected to the P region of the diode, and negative terminal of the battery is connected to N region of the diode. Whereas in reverse bias, the negative terminal of the battery is connected to the P side of the diode, and positive terminal of the battery is connected to the N side of the diode. So we'll see all the differences between the forward bias and the reverse bias. The first point is the definition itself. When the positive terminal of the battery is connected to P region and negative terminal to the N region, then the PN junction is said to be in forward bias. Whereas when the positive terminal of the battery is connected to the N region and negative terminal to the P region, then the PN junction is said to be in reverse bias. The current is due to the majority charge carriers, whereas in reverse bias the current is due to the minority charge carriers. The thickness of the depletion region decreases as the bias voltage increases. So this is in forward bias. So in reverse bias, the thickness of the depletion region increases as the bias voltage increases. The diode offers low resistance as it allows the current to flow through it very easily, whereas the diode offers a high resistance in reverse bias. A diode, ideal diode, in forward bias, it offers a zero resistance. So that's only for ideal diode. Whereas ideal diode in reverse bias, it offers infinite resistance. Just like we have the resistance of an ideal ammeter, which is 0, and the resistance of an ideal voltmeter, which is infinity. So here also for an ideal situation, for ideal case, 0 resistance in forward bias and infinite resistance in the reverse bias. And since the diode, it allows the charges to flow through them, diode acts as an on switch. Whereas the diode in the reverse bias, it acts as off switch. So based on this forward bias and the reverse bias, we can come to a conclusion that the diode has the ability to allow charges only in one direction. That is called unidirectional property. And it conducts only when it is in forward bias, and it doesn't conduct when it is in reverse bias. And this property of the unidirectional or ability to conduct in one direction is used in a circuit which is called as a rectifier. Rectifier. So first we will learn what exactly rectification is. The current which flows in a direction, in single direction, is called as direct current, or if the magnitude is constant, it's called as a steady direct current. And whenever the charges flows in either direction alternatively, then such a current is called as an alternating current. And we can always convert this alternating current to the direct current. So therefore, process of converting an alternating current to the direct current is called rectification. Process of converting an alternating current to direct current is called as rectification, and the circuit used for that purpose is called as a rectifier. So which device is used as a rectifier? Diode is used as a rectifier. So therefore, one of the important application of the diode, it is used in a circuit called as a rectifier. And what is a rectifier circuit? The circuit in which we can convert an alternating current to direct current is called as process is called as rectification, and that circuit is called as the rectifier. Now based on the number of diodes used, so we have three types of rectifier. One, half wave rectifier, full wave rectifier, and the bridge rectifier, and the third rectifier is not part of our syllabus, so therefore we will be learning only the first two circuits. So I am going to explain first half wave rectifier. Half wave rectifier. So first always learn the circuit used for it, and then the next is the waveform. So explanation is very easy to write. So in half wave rectifier we use a transformer. So this is a symbol used for the transformer. So this is the primary of the transformer. This is the secondary of the transformer. So when you draw the diagram, make sure that the number of turns in the secondary is lesser than the number of turns in the primary, because the type of the transformer that we are using is a step down transformer, and step down transformer, the number of turns in the secondary should be less compared to the number of turns in the primary. So this is the transformer, and then to the primary we connect an AC source. So this acts as the input voltage. Okay, so this is the AC source, and in the secondary we connect a diode, and then to a resistor which we call the load resistor, across which we measure the output voltage, and that output voltage will be always DC. So input voltage will be AC and output voltage what we get will be DC. So let us consider we are going to apply some voltage here. As an example, 230 volt AC I have applied across the primary of the circuit, and the waveform of that we are going to get something like this. So this is the input waveform, which is a sine wave. So this is input AC. Okay. Now this voltage is alternating, so that's why voltage varies in the primary. Not only voltage, the corresponding current also varies in the primary, and due to which it induces EMF in the secondary here. And since it is a step down transformer, we get the induced EMF will be lesser than that of the input. EMF induced in the secondary will be always less. Why? Because we are using a step down transformer. In step down transformer, the voltage it decreases. So if 230 volt AC is applied here, so we get a lesser voltage, and that lesser voltage, as an again example, let's take 10 volt AC, and this terminals here I am going to consider as A and then B. So across AB what we get is a lesser voltage, which is again an alternating. Now let us consider the one half of the AC. For one half of the AC I am going to assume that this end A is a positive and end B is a negative for first half of the AC. So in diode we have positive end of the diode, this is the negative end of the diode. Now if you look at the circuit, the positive end of the diode is connected to the positive terminal, negative to the negative. That means this diode is in forward bias, and when this diode is in forward bias, it conducts so that there is a flow of current through this part of the circuit. That means there is we do get some output voltage, and that voltage across this resistor is given. So this is that voltage which we are getting. That is for one half of the AC. For the next half of the AC, for the second half of the AC, this end A becomes a negative and end B becomes a positive, because it reverses the direction of the current. The polarity of the EMF changes. Plus becomes minus and minus becomes plus. Now if you see the polarity of the diode with respect to A and then with respect to B, this positive is now connected to the negative and the negative is connected to the positive. So diode is in which bias? So diode right now is in reverse bias, and when it is in reverse bias, so we know that it has unidirectional property. It conducts only when the diode is in the forward bias, so therefore it doesn't conduct. So the current through this is almost to zero. So now why I am using the word almost zero? Because there will be some current which is a very small current, which is of the order of 10 to the power minus 6. So that's why it conducts, but the conductivity is almost very less, or it's negligible. So that's why for a second half of the AC, we don't get any much current as well as no voltage here. So that's why the output voltage is almost zero. This is for the second half. So again, the polarity changes. It becomes, for the next cycle, this becomes positive, this becomes a negative. Now the diode will be again, so this is for the next cycle. For the next cycle, for the first half of the next cycle, the diode is in forward bias, so it conducts, so we do get voltage. For second half of the second cycle, the diode is in reverse bias, it doesn't conduct because it's in reverse bias, so we don't get any voltage. So this is how it goes for every cycle of the AC. And now if you compare the input voltage and the output voltage in the waveform, it's very clear that the input is always an AC because it changes both in magnitude and direction. But if you look at the output voltage, it is only in one half of the graph. We don't get voltage in the negative half, which means the kind of the voltage which we are getting is steady, not steady, it's oscillating, it's changing, but it is a voltage which is in one half. So that's why it is a direct current. The current what we get is a direct current, and the corresponding voltage what we get here is in one half, or it is unidirectional. So therefore this drawing the graph in the examination is a mandatory. It's a 5 marks question, very easy and simple. Practice first drawing the circuit diagram, transformer, AC source, diode and the load resistor, and across which we get the output voltage, and then waveform also have to draw in the examination. Very important 5 marks question. As I mentioned, either half wave or the next. Okay, by the way, why it's called as a half wave rectifier? Because we get output voltage corresponding to only one half of the AC. So this is one cycle, correct? So this is one half, second half, right? This is one full cycle. In that, only during one half of it we get the output voltage, and not during the next half. So that's why there is no output voltage during the second half. So that's what is called as half wave rectifier. So dear students, yesterday I have given the study plan, and if you implement it very seriously, you can complete your revision before the examination. So don't sit and waste your time. Don't sit and pray for the postponement of the examination. If it has to happen, it will, so don't worry about it. But you should be ready at any point of time in your preparation. So that's why my advice, suggestion, request is that start preparing from today itself. I have given a study pattern for the physics, and you can finish it very easily provided you are serious about it. And if you are not serious about it, so no one can help you. So we have already wasted enough time last year for the good reasons, or for the reason well known to each and every one of us. But here there is an opportunity, so they grab this chance. It's like a revision holiday given to you before the examination, and finish it very easily. You can complete the revision and follow the similar pattern even for the other subjects, so that you can score well. And again, if you have any doubts regarding any of the derivations, so tell me. I'm going to just record that particular part of the derivation, and I can forward that also. So therefore, first I will complete whatever the pending chapters in the remaining days, and then if you want me to explain particular derivation, I can explain here again on the board. I can record and then I can forward in the group. So therefore, it's you who have to take a step forward to continue your revision. So wasting time is very easy, but utilizing is the difficult task, and which you have to do it. So no one is going to come and help you out in regarding this. So therefore, start preparing, and you have ample of time to complete a revision in all the subjects. Okay. So wish you all the best, and I will continue with my next important question. As I mentioned, out of these two, definitely one of the question will appear in the examination. So we are done with the half wave rectifier. The next one is called as a full wave rectifier. Now, how different this circuit from the previous, you will come to know. The input part of the circuit is the same, there is no change. So this is the AC source, and in the secondary, as I mentioned, you have to draw lesser number of turns, and now the number of diodes are more here. So this is the first diode D1, and there is another diode D2, and then this circuit here, you close it and then extend it like this till the midpoint of the secondary. So this is that load resistor RL across which we find the output voltage, which is DC. So this is A here, so this is B, positive, negative, positive, negative. So this is the transformer. So hope you understood the difference here. Two diodes are used, and then the resistor has to be modified, and then this is called, this type of transformer is called as a center tap transformer. Center tap transformer, and so this is where you can generate a better output voltage. Okay, so let's see how exactly it works, and the waveform will always using the waveform, it's very easy to understand. Now, across the input, so this is here, we apply a 230 volt AC, and it induces EMF in the secondary, and the phenomenon involved in that transformer works on the phenomenon of a mutual induction. So therefore, due to mutual induction, it induces EMF in the secondary. And now let's consider like this. This is the waveform at A. So we will take one half of the AC. So this is positive and this is negative. So at A, this is one half. So terminal is a positive. At B, it is a negative, which is here. This is the input voltage at B. Remember, this is the input voltage at A, this is the input voltage at B. Now, look at the polarity, plus, 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 and this minus, understood? The minus with respect to this, clear? Minus and this minus. So this is positive, 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 negative, and then negative. So that means this diode is in forward bias. Look at the diode D2, negative, positive, and this negative and then positive. That means this diode is in reverse bias. So which conducts then out of D1 and D2? This is in forward bias, this is in reverse bias. Therefore, D1 conducts but D2 doesn't conduct. And when it conducts in this direction, because the current cannot flow in this because it's a reverse bias. So therefore, because of that, since there is a conductivity through R or RL, we get output voltage here. So this is due to D1. So it's written due to D1. Then for next half of the AC, see for second half of the AC. For second half of the AC, A becomes a negative and B becomes a positive. See, A is negative and B becomes positive. So now signs will help you in understanding the bias. Negative, positive, reverse bias, positive, positive, forward bias. So which conducts out of D1 and D2? So D2 conducts, but D1 doesn't conduct. And when it conducts, again it conducts in the same direction. See, it's in this direction only. Like if I have to take point M and N, it is from M to N. Earlier also it was from M to N. Even now also it is M to N only. And this is, so that means there is output voltage, and now this time this is due to D2. So that means for every half, any one of the diode will conduct. When D1 conducts, D2 doesn't, and when D2 conducts, D1 doesn't conduct. So that's why we get output voltage, which is definitely better than the half wave rectifier, and it's called full wave rectifier because we get output voltage for both the half of the AC. So this is an important question, either half wave rectifier or full wave rectifier, so can be expected in the board examination. Okay. So hope you have understood the applications of the diode, which is diode is used as a rectifier. And what is a rectifier? Circuit in which an alternating current can be converted into direct current. And how can you say that it's a direct current? Because there is the output only in one half of the graph, only in the positive half of the graph, which has to be an direct current or direct voltage, because if you get voltage in both the half, positive as well as negative, then it becomes alternating. So this has to be a direct, but it is not a steady voltage, it's an oscillating voltage, it changes. So we can make it constant or steady voltage with the help of the other circuit, which is called as a filter circuit. So students, again a reminder regarding your preparation. I don't have to mention again and again every time, but still as a reminder I am repeating this. So start your preparation without wasting time. So any help that is required regarding the preparation, you can always message me, I will guide you, but you have to initiate your preparation. Okay, so I will continue the remaining topic in the next class. Maybe in another 2 sessions I am going to complete this particular chapter, and then a part of the ray optics is also remaining, so that also I am going to complete in maybe last 2-3 sessions. So let me know your preparation level and what kind of help that you need from my side. So I am ready to guide you regarding your preparation. Okay, so I will see you again in one more session of the same